Okay, so it says there, so the quiz question. Oh boy, my pen, sorry, just 1 second. So, yeah, so they said the seat number, so the quiz question. Quiz says the seat numbers are consecutive integers. So they're consecutive, and then so that and then they say twice the smallest. Twice the smallest was 8 more than the largest. Was 8 more than largest. Yeah. Seat numbers, consecutive integers, twice smallest was 8 more than the largest. So that was how that went. So, okay. So, what do we do for consecutive integers? What formula do we always use? X and x plus 1, huh? Yeah, there's only 2 of these. What, 3? Oh, there's 3. Thank you. I should write that down, huh? Because there were 3 people, huh? Yeah, three people. I didn't know. So x plus 1, and x plus 2. Yeah, it just goes up by 1 every time. What if they say consecutive even or odd? What do we do in that case? If they say even or odd, we go up by 2 every time, huh? Because odd number to odd number is a jump of 2 every time. Even number to even number is just a jump of 1 every time. Oh. So there we go. So all right. So then it says twice the smallest. Who's the smallest? Isn't that one the smallest? Right, and this one's the medium, and this one's the largest. According to soda, small, medium, and large there, right? Small, medium, large. So twice the smallest, 2 times the smallest. What's was? Because that's past tense of is, huh? Was, equal to 8 more than, what's that? 8 added to, largest. It's x plus 2. Like that? We good? Okay. So there's our equation. You'll be able to do that today on today's exam.
Where's the middle?
Didn't need to use it. They didn't mention it. Yeah, no requirement that they have to mention all 3. So, all right, now how do we solve for x? Here's the wall. What do we do? Well, we do that when things are on the... Oh, yeah, you're right. I'm forgetting about the 8 and the 2. So the 8 and the 2 makes 10. Yeah, because the numbers... Here we have numbers or letters on the same side. You just combine them. Just add and subtract numbers and letters. Good. What do we do here now? Yeah, when you got x on opposite sides, you get rid of the lower one, right? So get rid of the x. Gonzo there. And so what do we got? X equals 10. Just like that. Are we good? Oh, we got to answer the questions, huh? So they're 10, 11, and 12 are the 3 seated. Because 10 is the smallest. X is the smallest. Yeah. And what option was that? That was E. That was a none of the above. You ready for those none of the aboves today? Sometimes it's none of the above. Take them out? No, none of the above. That way I keep you honest. Otherwise you could just, guess around. But every now and then, it's none of the above. All right, good. So any other questions? Are you guys feeling good about the exam today?
We have an exam on Friday too, right?
Yeah, it's double test week. So it's next week. Next week we have the 5th exam and the final. Yeah, back to back, Thursday, Friday. Boom, boom. Yes, this is the first of our 2 double test weeks. No fooling around. No, I'm just going to say look back at the other 5. The final is just a putting together of everything else. Yeah, so, all right. Well, let's, so our plan for the day, like I put on the board there, we're going to go into chapter 4 and cover that stuff. And then we'll take our exam the last hour like usual. You know the program. It's the usual program. Let me save those quiz results. And then we'll be off and running in that direction. That was our 12th quiz. Okay.
Aaron, do you happen to have a practice exam?
Yeah, I can grab it after.
Oh.
And today, what's today's date?
Yeah.
5th. All right, the 5th. Okay.
The YouTube video from Friday.
What's that?
Upload all the way, the YouTube video from lecture.
It didn't upload?
No, on YouTube. I
Like-
went to look for it and it was only like the second half.
Oh, the second half.
Yeah, for,
Huh.
was it 3.7?
Was it?
Yeah. It was
Hmm.
only from 10 to 13. I was
So only, problems number 10 to 13? Weird. I don't know what's going on. It's having troubles. Yeah, what's that happened before? Right? Oh no, that happened in my other class. Yeah, I don't know. Sorry. I guess some technology is not doing what it should do. All right, we are. All right. Let's take a look. The line graph reflects hourly readings of outside temperature during one fall day. Okay, so this is temperatures during fall. Okay. So, the temperature decreased from, the temperature decreased the most from boom to boom. So that's their question. All right, can you look at that graph and can you figure out, in which 1 hour, okay, I didn't read all the question. Yeah, it's a little tricky. So, in which 1 hour time period, did the temperature decrease the most?
From 10 to 11.
When is the steepest downward piece? I'm thinking it's like that. Isn't it this piece right here?
Well, they're not saying the lowest, they're saying the biggest jump.
The biggest drop. Yeah, the temperature decreased the most.
It's not
Or maybe it's that one, huh? I can't tell. See, that one goes from what, 40 it looks like, down to what, 34, drop of 6? It looks like to me. Is that what it looks like to you?
Yeah, the upper one looks like it's going from 50 to 48.
52, maybe?
No, yeah. 52 to 48.
48. Is that the same thing, drop of 4?
Take that.
Oh, no, the other one's drop of 6. Okay. Yeah, so this bottom one would be the winner. All right, drop of 6 from 40 to 34.
35. Yeah, 35.
35?
It looks like it's 35. Because it's between.
Boy, it's hard to tell, huh?
Yeah, you need a ruler.
Let's get a close-up look here. Yeah, it's not quite 34. It looks like 35. You're right. I'm thinking 35, huh? Did I not? Oh, nothing changed. Oh, it's changed on my screen. So I don't know why it doesn't project it up there. Yeah, whatever. So, technology, it's always beyond me. All right. So yeah, it looks like 35. I agree with you. So it's a drop from 40 to 35. From 40 to 35.
They want the hour.
Oh, you're right. They want the time, huh?
So from 10 to 11.
Is that what that is? It's from 10 to 11. Yeah, looking at these dots. Whoops, camera. Looking at these dots. Yeah, this dot's at 10 and this dot's at 11. From 10 to 11. That good? All right. There we go. So just looking at the graph, reading the graph. All is well. All right, so they want us to figure out, is 1, 2 a solution to that equation? What does that mean? How do you figure out if a point is like a 1, 2, couple numbers, is a solution to an equation. Just plug them in. Yeah, you just take that equation that y equals 8x plus 1. I'll bring it over here. And you plug in the 1 and the 2. Now, how do you plug in the 1 comma 2? Where's the 1 go?
First one X.
First one's x? Why is that? You sure?
Yes.
It is. And the only reason is just common agreement. Right? There's no logic there. They just said, hey, we'll make x first, then what? So that's just common. Same reason we drive on the right side of the road in North America, right? They don't in Europe, drive on the left side. It's just opinion of the people. So they just decided when it comes to like the two numbers with the parentheses and the comma, this kind of thing called ordered points, that's called an ordered pair, is what it's called, that x would be first, then y. Alphabetical. X is before y.
It wouldn't work if you switched it?
Right. It would not work if you switched it.
So what if the letters are like T and A?
Yeah, it goes alphabetical. So yeah, they decided just to go alphabetical. So usually they pick two letters like A and B, two right next to each other, A and B, or S and T, or they wouldn't pick A and they'd pick two letters close, and it's alphabetical.
Okay.
Yeah. So this one goes. So the 1 goes in the X, the 2 in the Y. So 2 equals 8 times 1 plus 1. Is that true? 2 equals 8 plus 1. Right. I just plugged in the 1 for X. And I plugged in the 2 for y. And I'm working it out. 2 equals 9. Is that true? No. So we'd say no. That's not. It's just a yes, no. So we just bubble the no option. If they came out equal, then those numbers would be a solution. Is that good? Okay. Okay. So y equals 4x plus 6 minus 7 minus 22. So give that a try. So go ahead and plug that in, see if it makes it true or not. Okay, so this is x, and this is y. So let's plug those in. So the x goes in the x slot, the y goes in the y slot. So minus 22 is 4 times minus 7 plus 6. Is that good? Now just work it out and see if it's true. That'd be minus 28, right? Positive times negative is negative. And then here, minus 28 plus 6 is minus 22. Is that true? Yeah. So this one's a yes. Meaning when you plug in minus 7 for x and minus 22 for y, they make the equation balanced. They make the equation true. The left side equals the right side. Are we good? All's well. Stop me if you want to talk more. Okay, so we have y equals 2x plus 6. And they're wanting us to complete the ordered pair. Look at that. Let me make it a little bit. Yeah, they're giving us 0, comma something over there. See what they're saying? Complete. Now, what does that mean? Complete the ordered pair.
Make it true.
Yeah, make it true. So how? That's right. So how do I do that exactly?
Plug in like the one number that you have.
Yeah, plug in the number that you have. Find out what the other number's got to be. That's right. Yeah. So what's the number that we have?
X. Or
Yeah, because it's right on. Because X is always first, right? Remember they go alphabetical, and Y is always second. That's right. So that first 0 that they're giving me, that's actually an X, isn't it? So I should plug that in for X. Here, let me move this over here and do that. So Y equals 2X plus 6. So plug that 0 in for X. Does that make sense there? And just put that 0 in for X. And then I can solve the little equation for Y. 2 times 0 is 0. 0 plus 6 is 6. So we bring that back, and the answer for the Y box is 6. So they gave me the X, I plug it in, and I solve for the Y that goes with it. We'll try now. They're giving me 2 more. So the next one is right here, and it's blank comma 12. So start with the same equation again. We're just going to redo the same equation 3 times. Now this one's going to be harder. So on this one, they want me to plug in that 12. They're giving me one number. Plug in the 12. Solve for the X. So where's the 12 going to go?
For the Y.
It's going to go in the Y because it's the second spot, huh? Because it's X first, then Y. So that 12 is a Y. So put that 12 in for Y. Like that. That makes sense. And solve for X, because it's X that's missing. So can you solve for X there? So how do we solve for, what do we do to solve for X? It's like a little wall, right? X is over here saying, I want to be alone. So what do we do first? Subtract the 6. So 12 minus 6 is 6. Last step in getting X alone is always divide by the identical twin. X is 3. So that means the 3 goes there, doesn't it? Is that good? And now, the third one is they say 3 comma blank xy. Same equation, third time. Y equals 2x plus 6. Can you do that one? So put 3 in for x. Like that. Y is 6 plus 6. Y is 12. So bring it back. Y is 12. We good? These easy for you? No problem? A little tedious, but 3 problems in 1 there. Okay, if I move on, everybody got that down? All right. Okay, so now there's going to want 4 of them. So we're starting with 6x minus 2y is minus 12. So try the first one there, 0, comma, blank. It's going to be 4 of them all together. Lots and lots of solving. So this is why we needed that last chapter, solving, because now we use solving in the world of graphing. Math always builds on itself. Every layer will build something new out of what we built last time. Coming out okay. So this is x, y. Put the 0 in for x. And what do we got? So this just, 6 times 0 is just 0. And so we just have minus 2y is minus 12 like that. How do we solve for y? Remember when it's always divide by the identical twin, huh? Same sign, same everything whenever we divide. And so what is that, 2 negatives? Positive or regular, 6. Good, so that's the y value there. Everybody good with that one? So next we start again and we take the second one in the list, which is blank, whoops, blank, comma 0, like that. 6x minus 2y is minus 12. Try that one. xy. Put the 0 in for y. Like so. Am I racing ahead of you? Y'all good? Did y'all finish out? And last step is divide by 6. Last step's always divide. So negative 2. Good on that one. We'll go on to the third one. So the third one we go again. Now we grab 4 comma blank. And that's xy. Again using 6x minus 2y is minus 12. But this time x is 4. So put in the 4 for x and solve for y. You guys are going to be solving pros, huh? Do this thing in your sleep easily. After 20 hours a week of solving for 4 weeks. All right, take that 4 and pop it in there for x. And then what's that? 24 minus 2y is minus 12. We good to there so far? And now y is saying, I want to be alone on my side of the wall. So what do we do to get y alone? Yeah, remember you save the minus 2 for last, huh? Get rid of the 24 first off. Subtract 24 from both sides. Gonzo. Minus 2y is minus 36. Is that good? And then last step is always divide by the identical twin. Y is positive. Okay, because two negatives make a positive there. Positive 18. Is that good? Questions on that one? Oh, and there's one more, huh? There's a fourth part. This one just keeps going and going and going. The fourth part is blank comma negative 30. So that's x, y, same equation. 6x minus 2y is negative 12. All right, can you do that one? I'm betting on minus 12. Is that what it is? So they're giving us y is minus 30. Plugging in y is minus 30. Work this out. 6x plus 60. Right? Two negatives make a positive there. Two negatives make a positive. And now we have to solve for x. How do we solve for x? Minus the 60. Because here's the wall, right? And so these are gonzo. So this is 6x equals minus 72. Like that, right? We good? Divide by 6. X is minus 12. You can read that down there. X is minus 12. Good? So those are tedious, huh? You okay with all those? Any questions on all those? That was all one problem. All right, I'm going to move on. So let's see. All right, so yeah, this one's a little different. So they're giving us, what's the equation? Yeah, it's right there. It's just x is 3. Notice it doesn't have a y, does it? There's no y. Okay.
That was really simple.
Yeah. So like in the first one, they're saying, all right, this is x, this is y, right? X first, then y, alphabetical. So they're giving me y as 1. Where do I plug that in? Throw it away, because there's no place to put in a y, is there? There's no y in this equation. If there was like a plus y over here or something, then I would take that 1 and plug it in. But there's not. There's no y at all. There's no y slot at all, so not going to do that. Well, then what am I going to do?
Plug in the 3.
Yeah, what does it say? X is 3. X is 3. Done. What am I going to do for the next one that says blank comma 1?
3.
X is 3. What do I do for the next one that says blank comma 3? X is 3. What do I do for the next one that says blank comma negative 4? X is 3. Done.
Why would they ask you that then?
They're just making sure you realize. So we're going to do something pretty soon, never long here in the summer, with equations that only have one letter. So they're just drilling home the idea. That baby's only got one letter. Remember? One letter. It's going to do something special when it comes to graphing. It's going to be a certain kind of graph. So just kind of making it really abundantly clear to you. Remember, this is special. This is special. It just means x is 3. Nothing else. X can't be 4. X can't be 2. Y, what can Y do? What, right, you know what I'm saying? All the X values have to be 3. No other choice. What about Y? What can Y do? Anything it wants. Right? Y can be 1, Y can be 3, Y can be -4, Y can be anything it wants. This equation says nothing about Y, limits Y not at all, but fixes X right at 3, doesn't it? So keep that in mind as we go to graph it. That's what that equation does. It hones X in at 3 and says Y, do whatever you want on that. All right. All right. So I'm supposed to take that graph. So there's our graph system, and it has an x-axis. See the x over here? It also has a y. I blew it up so you can't see the y anymore, but the y is the vertical axis. So it's basically 2 number lines. You guys seen this before? 2 number lines stacked vertically and horizontally. One sideways, one's vertical, right? What's it called? What's that whole thing called? Ever heard of the Cartesian coordinate system? So that's it. It's called the Cartesian coordinate system. Anyway, you got it. I'm not going to quiz you on the names, but anyway, it's just two axes. Yeah, just an x-axis and a y-axis, right? The middle is 0, 0. Can you tell they put each other right? The 0, 0. They connect right in the middle of 0, 0. And we're supposed to find some points. So they asked me to find the point -2, 1. That's going to be 1 dot on the screen. Remember, the first number is X and the second number is Y, always alphabetical. So they want me to find the dot -2, 1. So how do I find that?
Move over from the center dot
Yeah.
to -2 spaces, right?
Yeah. So start in the middle, right here in the center dot, and move. Do I go down 2?
You're on the x-axis on that first part, so it's going to go to the left.
Good. The first movement, the second one is up and down. So you got to remember that order matters. It'd be a different location. So starting from the middle, I'm going to go back 2. I'm going to go back 2, up 1 right there. That dot is the back 2, up 1 dot. Everybody see what I did there? So from the middle, I went back 2, up 1. Let's do a couple more. You guys have you draw a graph in front of you? So go ahead and if you have it, draw the same graph on your, just draw a big old couple axis lines, you know. Try the point 2, 1. How about 2, 1 instead of -2, 1? Can you put that one on your graph? I'll do that one different color here. So put 2, 1 on your graph. So where's 2, 1 in the graph? Yeah, so again, the first number's over, right? So over 2, up 1. Right there, there's 2, 1. So that's different than -2, 1, huh? Everybody making sense? So it's over 2, up 1 from the center. All right, let's try a third one. How about if we switch those numbers? How about if we go 1, 2? Yeah, find that point. That should be a different point. First number's over. First number's over. So over 1, up 2, right there. Over 1, up 2. Does that make sense? Again, first number's over, second number's up or down. How about if we take How about if we make both negative? How about -1, -2? Can you find that one? So how do we find that spot? Go back 1, down 2. Remember, first number's over again. Do you see that location? Back 1, down 2. Everybody see that? First number's over. Second number's up or down. So -2 is down 2. Back 1, down 2. You done this before? Finding points on graphs? So it's a big two-dimensional graphing system. XY axis, they call it sometimes. Questions I can answer on that? Is that all good? Oh yeah, let me show you how to do it on Math Excel. Oh, was that too small? Yeah, let me go back and make it bigger. They want us to get... Okay, there we go. All right, so let's try that one. Let's try the coordinates of point A. Let's start with that one. So what I mean coordinates, I mean they want us to say some kind of number, comma, number. So can you give the coordinates of point A? So try it on your own, and then I'll finish it on the board, or on the screen there. So what are the coordinates of point A? Something, comma, something. So first, so you go from the middle, right? From the this is called the origin, right in the middle. The origin, the beginning, the middle of the screen there. That's the origin. That's where everything starts, originates. So from there, the first number, remember the first number is over and the second number is up or down. The first number is an X, the second one's a Y, huh? So, from the middle, I've got to go back 1, 2, 3, 4, 5, 6. That was back 6, wasn't it? Does that make sense? Back 6 jumps, up 1, 2, 3, 4, 5. Up 5. So back 6, up 5. -6, comma, +5. That's the coordinates of point A. Everybody good? Want to try B? Try to get the coordinates of point B. So that's number, comma, number. Can you tell? First number's over again. Second number's up, down. So it's over 1, 2, whoops, kind of getting scribbly there. So it's over 1, 2, 3, 4. Down 1, 2, 3, 4, 5. Over 4, down 5. Over 4, down 5. Huh? Is that good? So to the right is positive, and up is positive, and down and left are negative. Try C. Can you get the coordinates of point C? Number, comma, number for C. So from the middle here, it's over 1, 2, 3, 4, 5, 6, up 1, 2, 3, 4, 5, over 6, up 5, both positive, huh? Right and up. Like so. And then finally, D. You're going to get the coordinates of point D. D might be a little more tricky. Give you a second on D. Get the coordinates of D. So it's back 1, 2, 3, 4, 5, 6. Back 6 up 0, huh? Back 6 up not at all. Back 6 up 0. There it is. Like good. So when you're on one of those grid lines, you got a 0 somewhere, don't you? You're up 0 if you're on the flat grid line there. Good? This is your favorite section so far? Straight ahead. These chapters always start out easy, huh? Then they get more complex. But those are the basic tools of graphing, finding coordinates on axis systems. All right. All right, so they give me y equals negative 2x plus 5, give me an equation. Y equals negative 2x plus 5. And then they want me to complete the xy table. Complete the xy table. So what are they talking about? Do you see what they're doing there? What are they making x be? 0. So they want me to take that 0 and pop it in for x, huh? Pop in that 0 for x and solve for y. So that'll be y equals negative 2 times 0 is 0. 0 plus 5 is 5. So that's 0, 5. So this is just like what we did before, huh? It's making sense? Nothing really new. Let's do the second part. Next, they say, okay, what's next one? Next one's going to be x is 1. What is the y value that goes with that? So x is 1. So start again, same equation, minus 2x plus 5. But this time you let x be 1. So put in x is 1. Like that. So put in x is 1. And we get minus 2 plus 5. That good? So that is 3. So that's the point 1. I could write it over here. 1. The other one we got was 0, 5, wasn't it? We good so far? Is that all making sense? How are we doing? You guys are awful quiet today. Let me know if there's anything you want to repeat.
We're scared of the test.
Scared of the test? Is this a more scary test than the last one? Or they're all just kind of scary?
Just the word problem.
Yeah, the word problems, really. All right. Well, let's do the third part. Y equals minus 2x plus 5. So what are we going to do for the third one? What are we going to plug in this time? 2. Now it's 2 for x. Well, if that's the case, maybe we could finish this up a little early and do a couple more of those word problems before we take the test. That'd be more helpful. So plug in the 2. Plug in the 2 there for the x. We good to there? We get 4 plus 5, positive 1. So y comes out positive 1. 2, 1. And we good? Questions on that one? So we're making little tables. You know what those are going to turn into in a little bit? Dots on a graph. So each of those is a dot, and then we'll play connect the dots, and you'll get a picture. That's how we're going to get pictures. So notice the process even now. Though all of these, like 0, 5, all of these 0, 5, 1, 3, 2, 1, they're all points that make the equation true, aren't they? We got them from solving. And so those will end up to be dots on the graph, and then we'll connect all the dots. So when you look at a graph, it's a bunch of dots that all make the equation true. You get the idea? That's how the graph is a picture of the truth of the equation. That's what a graph really is. We're kind of building up towards that. Graph's like a big light bright. Remember that old toy light bright where certain lights light up? The dots that get to light up on the picture are the ones that make it true from the equation. Math's so simple, isn't it?
If you go back to number 1, when you type in the names, they want you to make the graph.
They want you to put it on the ground.
Oh, okay.
So it's like a 4-part question.
Oh, okay.
So once
Let's
you
see.
plug in those values, it shows you 4 graphs and tells you to choose which one.
Oh, okay. Let's do it. All right, look at those graphs. How do you know which one's really right?
It helps if you, like on my screen, you click the.
Click them, you can make them big, the little magnifier, you get them a little bigger, yeah. Let's do this, though. Rather than look at them, I'm going to just do my own thing, and I'll pick it afterwards. In other words, I'm going to make my own little axis system here. And we've got these numbers over here, right? The 0, 5 first off. Now, what does 0, 5 mean? Remember first number? The first number is over. Remember that? First number is over. Second number is up or down. Right? So that means over 0, up 5. So starting in the middle. You always start in the middle. Start in the middle. Go over 0. Okay, I go nowhere. Up 5. 1, 2, 3, 4, 5. Put a dot. That's the over 0, up 5 dot. Good so far? Let's put, so I'm going to put all 3 of them on there. The next one is the 1, 3 dot. So that means over 1, up 3. Starting from the middle. Over 1, up 1, 2, 3. There it is. There's the over 1, up 3 dot. See how I'm finding these dots? When I'm done, I'm going to play connect the dots. And the third pair, these are pairs, right? They go together, like a pair of shoes. Paired, over 2, up 1, right? So over 2, up 1. So that dot right there is the over 2, up 1 dot. See how I found those 3? Now, let's play connect the dots. My graphing isn't the best, it's imperfect, but they sort of look lined up. They are exactly lined up if my graphing was more precise. They're exactly lined up. And what's the line? It's right like that, huh? Does that make sense? When we make that line, what we're really saying is that we've only found 3 dots, right? We've only found these 3 dots, but there's actually millions more. We're not seeing. Like if you kept going and going, you'd find all bunch of dots way out there, and also millions in between. Just like all in here, and they'd all fill in to make it a solid line. That's what that line really means. Is there's billions of little dots, all that what make it true, make this equation true. Remember how we got these numbers? Because when we plugged in it made it true. If you put in 0 for x and 5 for y, the thing is true. Right? You with me on that? Right? Like if I put in 0 for x and 5 for y, 5 for y, 0 for x there. Just do it right here. 5 for y, 0 for x. That's true. 5 does equal minus 2 times 0 plus 5. But if I had made this a 4 instead of a 5, that would not be true. 4 does not equal minus 2 times 0 plus 5. That's why over 0 up 4, this dot right here, is not on the graph. It's not on the line. Because over 0 up 4 does not make the equation true. That's the membership requirement. You get in the club if you make the equation true. You're on the graph of the line if you make the equation true. 0, 4 doesn't do it. So it's out. So remember, that's what that graph is right there. It's billions of dots that all make the equation true. So which one's the right answer then? A, B, C, or D? No brainer, huh? Once we did all that. That's called graphing. Does that make sense? All right.
Technology's wrong.
I know, it's frustrating, huh?
Yeah.
Because technology is completely inflexible. All right, so let's try. So here's the same thing, just a little harder when they're moving the things around on this one. So let's try this one. So when x is 2, what's the y value? So take the little equation, the x minus y equals 1, and we're going to put in the 2 for x. I mean, that one's a little more tricky. Let's see what you got. Let's see if you can solve that one. See how good you're doing it for equation solving. This one will push you a little bit more. I'll have some of these on today's test, where we got to solve things like this. I bet most of you can do it. I think after last week, we did some ugly ones. You can do it easy. So put in that 2 for x there. And solve for y. I know you can do it. Remember, don't forget that negative sign in front of the y, right? That's the main thing that could fool you, but I think you know it. So there's the wall. What do we do first to solve for y?
Insert the 2 to the x spot.
Yeah, right. Got that.
Okay.
Minus
So-
2.
Yeah.
So now got to get y alone. So it's minus the 2. Subtract the 2. Very good. That's gone, and we get minus y is, and what's the other side? Negative 1. 1 minus 2 is negative 1. Good. Now, remember how to get y alone? Y is not quite alone. He doesn't want that minus sign with him. He doesn't want anything with him. He wants to be totally alone. How do you get rid of that minus sign? Good job, guys. I knew you could do it. Divide by negative 1, right? Both sides, and then 2 negatives cancel. And then over here, 2 negatives cancel, positive 1. Y is positive 1. You remember all that? That'll be on today's test, that kind of thing. So I think you'll be good. So 2, 1. That's going to become a dot on the graph, isn't it? Over 2, up 1, dot, right? In a minute. We got to do the other two parts of this. So that's the first one that we did. Right over here, over 2, up 1. Now, next, they want us to do the second one. So in the middle, they're going to go, okay, x, y, and they're putting a 0. I'm just taking this one right here. A 0 in the y slot, and they want me to find x. So x minus, so same equation, just keep working with the same equation. X minus y equals 1. Now put the 0 in the y slot. Get x minus 0 is 1. What is x minus 0? That's just x, huh? That's just x. X is 1. So bring that back up. Or bring it over here if you want. That's 1, 0. Everybody tracking with me?
Why wouldn't you put the 0 on both sides and add 0 to itself and 1
Oh, yeah, you could. But I just know taking away 0 is nothing. Kind of like when I have 1 times x is 7 or something, I don't divide by 1. I just look and go, 1 times x, that's just x. But you're right. I mean, that's not illegal or anything. If I added 0 to both sides, what would 1 plus 0 be? Yeah, so it just feels like a wasted step to me, but it's okay. It's not wrong or anything. Good question, Neil. Good with that. How about the third one now? The third one is 0 comma something. So we do an XY table. They're giving me 0 for x. They want me to find y. So we got x minus y is 1 again. This time 0 for x. Finish that one up. Screen there. Okay, now 0 minus y, that's just minus y, isn't it? How do you solve for y? Divide both sides by -1. Y is -1. Y is -1. Second.
Can't you just take that and make it a negative, just change it to a negative instead of doing that last division step, or is that really necessary? Like
Yeah, you're right. Yeah, when you have, you mean when you're looking at negative y equals 1, just say, okay, so y is -1. Yeah,
That works
Yeah.
always.
that's true. Yeah, that'll always work. All right, and then what are they going to have us do with those 3? Those are 3, but even though there's 6 numbers, what was the first one? 2, 1. Even though there's 6 numbers, it's 3 dots on the graph, right? Because 2 numbers make 1 dot, don't they? So could we put all those on a big graph now? Put a graph right here. Can you put those 3 dots on the graph? We just solve for 3 dots. Can you put them on the graph? Remember, first number's over, second number's up or down, right? The x is the over, the y is the up, down. So the first one, over 2, up 1. Over 2, up 1. Is that good? Over 2, up 1. Second one, the 1, 0, right? So find that dot. That's over 1, up 0. Everybody good there? That one's on the grid line because it went up 0. The third one, the blue one, is what? Over 0, down 1. So starting in the middle, always starting in the middle. Over 0, okay, I went over 0, down 1. Right there. Over 0, down 1, huh? See those 3 dots? They're all lined up. And by the way, if they don't come out lined up, you made a mistake. They should always come out in a straight line. So then you play connect the dots. There's our graph. And that graph shows more than our 3 dots. It shows billions of dots all connected up, making a straight line. And that line goes forever up and forever down. Good? Questions on all that? All right. Okay, so all that was kind of just getting us warmed up. Now they're giving me y equals 3 minus 4x. And they want me to graph the whole thing. Like, they're not giving me any points or anything. They just want me to do the whole thing. Is this making sense? So what I'm going to do is I'm going to pick my own points. I'm going to make a little XY chart. And I'm just gonna say, okay, they're not giving me any. I need some dots, right? I need some dots to put on a graph and connect the dots, and then I'll know which of these 4 pictures is the right picture after I've made my own picture. Is that good? So how do I make my own picture? Well, you got to have some numbers. What numbers? Pick any number. What's the easiest number you know? You can pick any number you want. What's the easiest number you know?
0.
Me too. 0 is the easiest number I know, followed by 1. How about we start with 0 and then do 1? Keep it as easy as we can. You can do any numbers you want. We just got to get some dots on the graph. Remember, those lines have millions of dots, right? So we're just getting a couple of them.
Try not to get any decimal, right?
Oh, yeah. We don't want to do decimals. We only want negatives if we can avoid it. Yeah. So let's go do that. So what am I talking about doing that? I'm saying just plug those in for x into that equation. So notice I just take that equation. Y equals 4x minus, y equals 3 minus 4x. And I put in the 0 for x. Like that. And what do I get? 3 minus 0, y is 3. Is that good so far? Now, let's try again. So now we start again with y equals 3 minus 4x. This time we put in 1 for x. 3 minus 4 times 1. What's that? 3 minus 4, negative 1? Am I going too quick? Let me slow down there a little bit. Everybody see what's happening? And they got negative 1. Is that good? So I have to, I'm graphing, and so I just made up a little XY chart, and I just put 0 and 1 for x because they're the easiest numbers I know. And I just took my equation and I plugged in 0 for x, got 3. So the y value is 3 that goes with the x0. And then I put in 1 for x. The y came out negative 1, which goes with the x positive 1. Is that good? Everybody see what I'm doing there? I'm just starting with x0 and x1 because they're easy. Plugging them in, finding the y values that go with them. And I can go to the graph now. That's all I need.
That makes sense, but when you say you can pick any number, I don't understand.
Yeah, I'll explain. After we have our graph, it'll make more sense, I think. So let's go to our actual graph now. So our actual graph. So now, let's put on our graph the dots we have found. Remember, 2 numbers make 1 dot, don't they? 1 location. So 0, 3. Can you put that 1 dot on our graph? Remember, first number's over. Second number is up or down. Positive up, negative down. So over 0, up 3. 1, 2, 3. Over 0, up 3. The second number is over 1, down 1. Am I going too fast? Does that make sense? So the first dot is over 0, up 3. The second is over 1, down 1. Those are my 4 numbers, but 2 dots. And now, play connect the dots. So there it is, huh? There's our line. Can you tell which of those is the right line? It goes down to the right, so it's A or D. First off, we good with that much? See how it's either A or D, because those both go down to the right?
No, it's D, or A, because it goes up to 2.
Yeah, and it is A in the end, because in the middle, it hits above the middle, whereas D is hitting below the middle. A is hitting above the middle and going down to the right. It's A. Everybody see that? See how we got the picture? Questions I can answer? Is that making sense? Please give me a nod, a yeah or no. It's making no sense at all, or no. If questions I can answer, I know whether to speed up or slow down.
Going good.
It's all good. That okay? So everybody see what I did? I just made that table. I just said, hey, this is the first time they haven't given me numbers. I just came up with my own numbers. I made an XY table, and so what did I do? Well, if I come up with my own numbers, I'm going to do the easiest ones I can. So I just picked the easiest two numbers I know, 0 and 1 for X, plugged them into the equation, got the Y numbers with it, put the two dots, connected the dots. I could tell it was graph A. So that's how we graph. That's one way.
But that would work with any number, right?
Other than, yeah. Oh, yeah. No, I got to get back to Melody's question, which is good. But like, what do I mean that would work with any number? Yeah. Well, really, there's more than those two dots, right? There's infinite. This line goes forever. There's infinite dots, huh? Those are other X values. Like I could have gone way over, let me see, let me go way over to 3. Let me just pick a number. Here's where 4, 5, here I'll go 5. I'll go way over to X5. There is some dots way down here. It looks like it's over 5, down a bunch. I don't know how much. There is some dot there. You could go in there, let's go find it. Put in X as 5. What if I had chosen X as 5? What would I have gotten for Y? There's no room. Well, here, let me make room. Let's do it. If I'd done X as 5, X's, I take the same equation. We never change the equation. And then plug that in for X. What are you going to get? 3 minus 4 times 5. 3 minus 20, right? 4 times 20. What's 3 minus 20? Negative 17. So that's over 5, down 17. See, we knew it was way down. We could have had that dot and one of the other dots and connected them, and we would have got the same exact line, wouldn't we?
So is it the formula? The formula is what gives us...
The formula is determining the line. Exactly. It doesn't matter what X you plugged in, you're going to find some dot on that thin line. Yeah, that's right. And then you have two dots, these two, or those two, or these two, whatever. Any two connect up, you'll have the same line.
I was thinking it was gonna make the line go more like this, but it's not, it's still gonna be that
Yeah,
same.
this line is that equation.
Yeah.
All the dots that make this equation true are on that line. Yeah, so any X you want to plug in, you'll get some dot on that line. That's why I think, well, let's just use the easiest X we can. If any numbers work, how about just 0 and 1? That's why I'm picking that, yeah.
If you get a decimal, try a different number, is that reasonable?
Yeah, if you plug in, you get something ugly, go, yeah, let me redo it. Yeah, you could do that. Yeah, that's true. Yeah, you ever thought about graphing this way before? This is what graphing really is, a big light bright. It's a bunch of dots that make the equation true. I mean, I use that analogy. It's important to think that way, even if you're just beginning graphing now, all the way through calculus. I mean, I teach 5 summers I've taught calculus, and I get all the big university calc here in the summer. We're one of the only, Fresno State doesn't do calc, and so we get like university students. I've had Berkeley students and people come and take my classes. Michigan State, one semester, my top student was Berkeley, followed by Michigan State, followed by, they're here taking my calc in the summer, and I'd be doing the graphs on the board and stuff. And I remember, and we had some dots, some big fancy equation, and we had some dot on a graph. I'm like, all right, guys, dot on the graph. What does that mean? I remember them all just kind of looking at me, and I'm like, come on, calculus students. Dot on a graph, what does it mean when you're a dot on a graph? You make the equation true, what we're saying right here and now. That never ceases to be the case. What does it mean that this dot is on this line? How did it get to be on that line? Because 5 for X and negative 17 for Y makes the equation true, doesn't it? That's important, and it's easy to forget it when you go into up the line in math. That's what a graph is, a picture of all the dots that make it true. And you use that as you move up the line in mathematics. All right, so
Is it usually easier to substitute x than to do it for y? Like to make up your number for
it
x?
depends how the equation is written.
Okay.
Yeah, we'll start changing things around a little bit when they change things around. Yeah, we'll talk about that. Okay. Yeah, this is a good one to do. Okay, so here's what they're doing on this question. They're giving us this equation. 2x minus 3y equals 6. And then they started with 0. Now, I answered the question -2, but could you do that? Let's make sure you can. 2x minus 3y is 6. 2x minus 3y is 6. And they're giving me x. Remember, it's x first, then y, huh? They're giving me x is 0. X first, then y. They're giving me x is 0, find y. So they're giving me x is 0. So they want me to take that 0 and put it in for x. So take that 0, put it in for x. See how we're doing there? And then can you solve that for y? I already did. I got -2. See if you can get that. All right, put in 0 for x. And solve for y.
What makes the difference about the line and the dots? That's
What's that?
like,
Oh, why are they putting a couple dots? Yeah, I have no idea. That's weird. It's not B and C.
it can't be being.
Or maybe I'm wrong.
'Cause it looks
Complete
like
the ordered
it's-
pairs, then graph the equation. Choose the graph of the equation.
They don't want the dots, they want the line.
Yeah, they want the whole line. Yeah, I don't know why they're putting those dots on there. That's just kind of weird.
They just throw you off.
Yeah, because I chose the dots when it's wrong.
And they told
Yeah, don't choose the dots.
and then they told us the line.
Yeah, and the reason we know on that is because they're saying graph the equation, not just the dot. The equation's the whole line, millions of dots. Just the original 2 dots indicate to us how the millions of dots play out.
Okay.
If they said just graph these dots, then, but they didn't, they said graph the equation. So, all right, so let's get that. So that's 0 minus 3y is 6. That's minus 3y 6. How do you solve for y there? Well, I said I won't be alone. Divide by -3. So y is -2. So that's how I got the -2. Does that make sense? Guys with me there? Now do the second one. So the second one, again, start with 2x minus 3y is 6. And the second one, excuse me, is something comma 0. See right here? Now I already found that x is 3. That was the answer I discovered. But they were giving me x comma y, where the y is 0. So put the 0 in for y, like that. Put that 0 in for y. And solve that equation for x. Three times 0? 0, so it's 2x is 6. Good, right? 2x take away nothing. Right, Elizabeth, I'm not going to add the 0 there. And then how do you solve for x? Divide by the 2. x is 3. So that's how I got the 3, 0. Does that make sense? And now put those 2 dots on the graph. Here, I'll just do it right here first off. So put those 2 dots on the graph, the 3, 0, and the 0, negative 2. Over 0, down 2. And the other one, over 3, up 0. Like that. Those are 2 dots, we good? And then connect the dots. There's the line. So it's A, isn't it? They're trying to fool us on C because they're giving us the 2 dots on C. Those are the right 2 dots, but it's not the whole equation. We good? That easy? So I'm going to skip a bunch of those from now on. I think you got it. No questions? Yeah. So here's number 11. And they're giving me y equals minus x. They want me to take that and graph it. Now this time they're not giving me any numbers. No numbers. So what am I going to do? Make our own. Remember what we did before? Make our own XY table. You can put any numbers you want. Remember, because there's millions of dots on that line. So we can pick any. All we need is 2, right? All you need is 2 dots, and then you can make the line, right? So pick 2 x values. What are your favorite, at least your easiest? 2 numbers. 0 and 1. Yeah. Like that. 0 and 1. We good? Put in 0, put in 1. All right, so that when you plug those in to y equals negative x, so it's y equals negative, so put in 0. What is negative 0?
0.
Yeah, it's just 0, right? No such thing as negative 0. And then put in 1. That's just negative 1. That was easy. Now, can you make a little graph and put those 2 dots, 4 numbers, 2 dots on the graph? What's the first one? 0, 0. That is the origin. It's right smack in the middle, huh? 0, 0. Where's the other dot? Now it's over and then up, down, right? Positive, up, negative, down. So over 1, is that to the right or the left? Right. So over 1, and then what? Down 1. Right there. There's over 1, down 1. This is 0, 0. That make sense? Over 1, down 1. 0, 0, and over 1, down 1. And now we connect the dots. There's the line. So which one is it? A, B, C, or D? Easy, huh? So you see how to graph an equation? They give you an equation. You just make your own table. Put in 0 for x and 1 for x. Plug them in. Get the y values.
Question, Mr. Rankin?
Yeah.
So,
Julio.
I think I know the answer, but I just want to clarify. If we put negative 1 at negative in the x-axis, like a negative 1, for example.
Yeah.
So you got the negative sign from the x.
Yeah.
You double negative.
Yeah.
Positive.
Exactly. Well said. Yeah. Like what if I had put in negative 1 for x into the equation y equals negative? So it would be y equals negative, negative 1.
Yeah.
That's right, because you're plugging in negative 1 and there's already the negative in the formula.
Okay.
Yeah. So y would end up positive 1, wouldn't it? Is that on the graph? Over. How do you go over negative 1? getting all messed up here. You go back one, up one. Look at that. It's beautiful. Back one up. See, it's another dot in the graph. Those two dots would have connected to make the same exact line. Any dots that make the equation true are on the line. They'll all line up in a perfect straight line. Good. 15, we're getting close. We'll have some time to do a couple of word problems. All right, so let's try that one. We'll go about 15 more minutes, take a break, and then come back and do some word problems together before we do the test. So y equals 3x. Can you graph that one? So same kind of thing. Go ahead and just, they're not giving you any numbers, so make your own table, your own numbers. And what two numbers are you going to put into your table? 0 and 1, because they're easy.
Are we coming up with just 1 point or more than?
Need two. Yeah, need two dots to make a line, right? Two dots, then you can connect them in another line. So that's why you plug in x is 0 and x is 1. 4 numbers, 2 dots. Am I making any sense? So you do an xy table. You let x be 0 and x be 1. Plug in, then take the original equation, y equals 3x, and plug in 0 first off. And what is 3 times 0? Well, 0. So bring back the y. So that's the 0, 0 dot. Good so far. Now, do the next one. So now we're going to go again with y equals 3x, but this time we're going to plug in what? X is 1. So plug in x is 1. So 3 times 1 is 3. So we got a couple of dots. Can you put those on the graph? So I'll make a little graph down here. So first one, 0, 0, where's that? That's the origin, right smack dab in the middle there, over 0, up 0. And then the second one is 1, 3, so that's over 1, up 3, like so. First number's over, second number's up, down. Is that good? And now, what do we do with those 2 dots? Connect the dots. There's our line. We graphed the equation y equals 3x. What is that graph? Millions and millions and millions of dots that all make the equation true, don't they? They all make the equation true. Is that good? Now, let me show you how to do the graph maker tool. Because they're going to have you actually, it's not multiple choice. This is the first one that's going to not be a multiple choice answer. It's going to be a make your own graph with our graph maker tool. So let me show you how to do that. So we got the 2 points, right? 0, 0, and 1, 3. We good to there? If I flash off. Okay, so try that one. I don't know what the other ones are. Let me just make something up. Maybe it's 3, 0. How about that? All right. So find the x values that go there. So there's our equation. Yeah. So we good with that again? We're just making sure you're clear with that again. When there's only one letter, like just x equals 1, there's nothing to do and actually like solve or anything, huh? It's just x is 1, x is 1, x is 1. Right? X first, then y. X is always 1. X is just always 1. Okay, what does that mean about a graph? Good there? So there's nothing to solve. They're telling me x is 1. Just put in 1 for x. Now, when it comes to my graph, how do I actually make the graph? What's it going to do? Yeah. Let's put the dots here. Let's start with the 1, 2.
Oh, 1, 2, 3.
So over 1, up 2. Good there so far? Over 1, up 2.
Great, up two or up three?
I did this one first up.
Oh, okay.
The over 1, up 2. And now I'll do the over 1, up 3. Over 1, up 3. And now I'll do the over 1, up 0. And now we're going to connect the dots. We actually only needed 2. That was overkill. What kind of lines are going to look like? Straight up and down. Yeah, when you have only one letter, then you get a perfectly vertical. Or if you'll have only x, it's perfectly vertical. Guess what if they give you an equation that only has y and doesn't have x at all? Perfectly horizontal, like the horizon. Yeah, that's what it's going to do. So you just know that. That'll become useful in the next couple of sections. When they give you only one letter, you think, oh, I know that. It's a vertical line or a horizontal line. Right away. There's no slant to it, in other words, when it only has one letter, huh? Good. So they're giving me y, so I'm going to just make up 1, 0, I don't know what they are, but good enough. So they're giving me y is -4. See what you can do, and then after that go to the graph. All right, so what do I do with y equals -4? I put in -4 for the y value. We have x and then y. I just keep putting in -4 for the y value. Go to the graph. Put those 3 dots on the graph. So over 2, down 4. We good for starters? Over 2, down 4. And then the next one is over 1, down 4. The next one is over 0, down 4. Did you guys get those 3 dots? And last step is always to play connect the dots. There's the line. We good? All right, I'll move. Okay, so now they're giving me the equation y equals -1, and they want me to figure out which of those 4 graphs it is. So how do we graph when they give us an equation? What do we do? So normally we can go through the formalities, make an XY chart, right? Now it's going to be different though. Normally. Well, I mean, I guess we could do it here. We put 0 and 1. I mean, that's fine, I guess. We can do that. 0 and 1. Right? When we make our own tables, we just put 0 and 1 for x like that. What are the y values going to be? Yeah, there's no options, just -1. So put those dots on the graph. First number's over, second number's up or down. Right? Over 0, down 1, right there. Right? Over 0, down 1. Over 1, down 1, right there. Connect the dots. There it is. Which one is it? Yeah, B, huh? See how that worked? Flat line. Over 0, down 1. Over 1, down 1. Connect the dots, flat line. So like we said, when you only got y, you got a flat line. When you only got x, you got a vertical line, huh? If you have both letters, you have some slant. All right, that's it for that. We finished 4.1, 4.2. Let's stop. Let's take,